Okay, so this video is focused on changes in velocity, also known as acceleration on position time graphs. As a review, acceleration, or maybe a reminder, acceleration is the rate of change of velocity, and velocity is basically how an object is moving, including both speed, how fast we're moving, and direction. So if we look at this first example here, I am driving to the right, and I start at home. So home is our zero line here, where we have position on our y-axis and time on our x-axis, as is always the case in our position time graphs. Now, if you've seen other videos, if you've been keeping up, then you would probably be able to translate this, hopefully, relatively easily. So if I start at home but drive slowly to the right, I need to draw this with a pretty shallow slope because I'm moving slowly. I'm drawing the slope as positive or as sloping upwards because I'm moving to the right. That, by our sign convention, is a positive direction. Then I move slightly faster to the right. So still moving to the right, so I'm still going to draw myself moving in this positive direction or up on the y-axis. But now that I'm moving faster, I'm going to draw a slightly steeper slope for this purple section. And then the last section, I am moving even faster to the right. So I start off moving slowly to the right, then a little faster to the right, then even faster to the right. So I need an even steeper slope. That's a pretty messy line, but the point still stands. Now, based on this, the way that this story was written and the position time graph, the way I've drawn it, it looks like I moved at one speed for however long. Maybe I was driving at 25 miles per hour for 10 seconds. Then I was driving maybe at 40 miles per hour for 10 seconds. And then in this green section, maybe I was now moving at 60 miles per hour for however long this line would go on for. What's more realistic, though, is not that I was moving in all of these different sections of motion with a very discrete changes in my speed. More realistically, it changed on a slight curve, right? So when we have acceleration or these changes in velocity where we can see I'm speeding up on this graph, we get curves on our position time graph. Because you could imagine if I instead of having just 3 sections, if I had 1,000 of these little sections of speeding up, it would resemble or look just like a curve like this. And we can see when we are analyzing curves on position time graphs, we could tell that this person or object is speeding up because as we move forward in time, their graph gets steeper and steeper. And on a position time graph, we know that steepness tells us something about that object's speed. Now, let's look at another example of how we can break down these sections and then sort of translate that into a curve if we were just told that someone is speeding up or slowing down. So now let's look at this example. I'm still driving to the right, but now I'm driving quickly at first. So I'm going to draw myself moving very quickly to the right. So a really steep line showing that I'm moving really fast, and then upwards because I'm moving to the right. That's a positive direction. So if we're looking at our position, a positive y value there, or in the direction of positive y values. Then I drive slower to the right. So if I'm moving still to the right, I still need to be slanting upwards. But since I'm moving slower, I'm going to draw a slightly less steep slope. That's positive. And at the end, I have an even slower velocity still to the right. And so you could imagine if, and take a second if you haven't already, you might have already done this as you're watching this, try to predict what this curve would look like. And it's pretty obvious, but take a second to just picture that. Probably looks something like this. Right? Here we can see someone or something slowing down because the slope is getting less and less steep or more and more shallow as time moves on. And they're slowing down in the positive direction, or in this case to the right, because their slope is positive the entire time, even though the slope is getting smaller. It's staying positive the whole time. Now let's look at Just two more quick examples. This will get very repetitive, but this sort of covers all of the different instances that we would need to sort of understand or recognize on position time graphs. Now I'm starting at home. I drive slowly to the left at first, because now we're told that I'm driving left. So if I'm driving left, left is negative on a coordinate plane. So for our positions, that's towards the negative direction, or towards our negative y values. So if I drive slowly at first, I'm going to draw a very shallow slope at first, heading in the negative direction. Then I drive faster to the left. So I'm going to draw still a slope towards these negative numbers, or in the direction of negative positions, but steeper because now I'm moving faster that way. Then at the end, I move even faster to the left. And we could imagine if we had to draw a curve, if all we were told, instead of having these distinct sections of first I move slowly, then even slower or faster, we could draw a curve to resemble this motion, showing that I am speeding up in the negative direction. Speeding up because as time goes on, this graph is getting steeper and steeper, or the slope would get steeper and steeper, and in the negative direction because we are moving, or I am moving towards negative y values, towards these negative positions. Okay, so one last example. Now let's look at me driving left still. Driving left, starting at home, I drive quickly at first. So I'm going to draw a very steep slope in the negative direction because I'm driving left, a negative position, so we need to draw these this moving towards our negative positions. Then I drive slower to the left. And then at the end, I drive even slower to the left. Almost at rest. So here what we can see, if we drew a curve to represent this, instead of these distinct motions, we could show this with a curve. If all we were told is Mr. Eckert drives left and slows down as he does that, we would probably draw that with this acceleration, with a curve on our position time graph. We can tell we're slowing down because as time moves forward, these slopes are getting less and less steep, and we can tell that I'm slowing down in the negative direction because even though I'm slowing down, I'm still moving to the left the entire time, and I'm still sloping towards these further negative positions. So all four of those shapes are really the only four shapes that we would need to know for these like constant acceleration situations on a position time graph. But instead of memorizing these, I would definitely encourage you to just sort of practice, making sure that if you see a curve like this on a position time graph, that you can reason through, is this speeding up or slowing down? Is this moving in the positive or negative direction? Because those are the questions that will save you a lot of time and allow you to not just memorize things and actually be able to think through these problems.